Okay, starting with number 6 on the quiz. So in number 6, what we have to do is factor out the denominator, because as we approach x equal to 2, we get division by 0 in the denominator. So we want to see if this can be a removable discontinuity by factoring out the denominator. So if we factor out the denominator, x squared minus x minus 2 becomes x minus 2 quantity times x plus 1 quantity, and then these two cancel. That leaves us with 1 over x plus 1, and there's no longer division by 0 if we put in a quantity of 2 and do direct substitution. So therefore the limit as this approaches 2 is 1 over 3. Okay. There were some people that when they canceled, they left only the x plus 1 and they put it in the numerator, and that would be incorrect. So you have to remember that when you cancel factors and there's no factors that are left, there's always an implied factor of 1 in front of everything. Okay? So when you cancel two terms, make sure that you do not mess that up. Okay, so next problem. There were some people that had some difficulty with this because they did not know how to factor x cubed minus 27. They didn't know how to start or what to do with that. The one factor that you want to check to see whether or not there will be a cancellation is x minus 3. So you don't have to guess as to what these quantities are. You can just try to see whether or not x minus 3 divides out x cubed minus 27 evenly. And to do that, you use polynomial long division. So we put x minus 3 and we divide that, we take x cubed minus 27, write it out as in decreasing powers of x, and if it doesn't have a value, its implied coefficient is 0, so we would write x cubed, then we would write plus 0 x squared plus 0x minus 27, and we are seeing how many times that x minus 3 goes into that, so we put that out here. So we see that if we wanted to get x cubed, right, we would multiply x by a quantity of x squared, and that would give us x cubed. Then we also have to multiply that to whatever is in the other terms. So we get x squared times negative 3 gives us minus 3x squared. Then we would subtract the first two terms here by the terms here, and we are left with x cubed minus x cubed is 0. 0x squared minus negative 3x squared is plus 3x squared. And there's a couple of problems like this on the pre-calc review sheet. So we continue this process out until we arrive at a quantity of x squared plus 3x plus 9, and we note that we also have a 0 remainder there, so that means that this quantity is exactly equal to x cubed minus 27 divided by x plus 3. So we know that it factors out evenly. So we can rewrite x cubed minus 27 as the quantity of x minus 3 times the quantity of x squared plus 3x plus 9. And that means that a quantity of x minus 3 cancels in the numerator and cancels in the denominator, leaving us only with x squared plus 3x plus 9. And there's no reason that we can't use direct substitution on this. And so when we do use direct substitution, we get 3 squared plus 3 squared plus 9, which is 9 plus 9 plus 9, or 9 times 3, which is 27. Okay, find the limit analytically of 2x plus 5. So 2x plus 5, just a regular polynomial. Polynomials are continuous everywhere, so the limits are defined everywhere, so we can use direct substitution on this. So when we use direct substitution on this, this is 2 times negative 3 plus 5, which is negative 6 plus 5, which is negative 1. Okay, number 9, find the limit analytically. Let me check my time on this. Doing good. So x squared plus 1, again, this is a polynomial. We can use direct substitution when we do that. We get 4 squared, which is 16, plus 1, which is 17. Okay, next problem, x squared minus 2x minus 8. The numerator this time factors into the quantity of x minus 4 times x plus 2. We couldn't use direct substitution because we would get division by 0, so we can see if we can make this into a removable discontinuity, and we can because it factors nicely, and we can cancel the numerator and the denominator, so this leaves us with a quantity of 6. Okay, when we use direct substitution. Okay, so number 11. Number 11 looks like a lot like the problem number 1 on the first page there, So what we do is we rationalize by factoring, or by multiplying by using the definition of perfect difference of perfect squares to see if we can remove some of these radical signs in the numerator. So when we multiply square root of x plus 3 minus square root of 3, and we multiply that to the square root of x plus 3 plus 3, so there's a difference in signs of a positive and a negative there. That will give us a sum of, a difference of perfect squares. So this will become square root of x plus 3 squared, which just becomes x plus 3, and minus the square root of 3 squared, which the plus 3 and the minus 3 will cancel additively in the numerator. This will leave us with x over x times the square root of x plus 3 plus the square root of 3. The x's will cancel, leaving me 1 over the square root of x plus 3 plus the square root of 3. And that is 1 over 2 times the square root of 3. There were a number of people which rationalized the denominator when they were done with this by multiplying, by multiplying the numerator and denominator by square root of 3, which equals square root 3 over 6, which is fine as well. So this answer is correct. Just as much as 1 over 2 times the square root of 3 is correct. It all depends on how you might use it later. Okay? Alright, so number 12 we have, let me check my time. One moment. Okay, doing good. Alright, so we have in number 12 1 over x plus 7 minus 1 over 7 divided by x. Now remember that this is the same thing as division by a fraction, and we can rewrite x as x over 1 is the same thing as multiplication by its reciprocal. So we can take this quantity, and instead of dividing it by x, we can multiply it by the reciprocal of x, which is 1 over x. Another way of just thinking about it is a lot of times we'll just say that we take out a 1 over x from this. But that's the underlying logic behind it. So we consider the numerator first, and we'll bring out this 1 over x and multiply it back in once we are done figuring out what we should do with the numerator. In the numerator we have 2 different fractions, 1 over x plus 7, and that's subtracted, we subtract 1 over 7 from that. So what we can do is combine these 2 fractions together. So this fraction is missing a factor of 7 in the denominator, so we multiply 7 on the top and bottom. This fraction is missing a factor of x plus 7, so we multiply x plus 7 on the top and the bottom of this fraction. Then both fractions will have a common denominator once we do those things, and so we can combine the numerators together and share a common denominator. So this will give us 7 minus the quantity of x plus 7, which becomes 7 minus x minus 7. The 7's will cancel, leaving us only with negative x on the top. Then we can say, alright, well, This is as simple as I can get this, and there is a factor of 1 over x on the outside, so this 1 over x will cancel with this factor of x in the numerator there, leaving us with only -1 on the top. Some people canceled out the negative sign, which was incorrect. And then once we do that, this was the only thing keeping us from doing our direct substitution. So when we directly substitute 0 into -1 over 7 times the quantity of x plus 7, it gives us -1 over 49, which is the final answer. Okay, number 13. A lot of people had problems with number 13. Some people did it correctly. Some people did not. Remember that whatever is inside of a function cannot come outside of the function. Unless it's evaluated directly or you know some special property of the function. So when I say cosine of pi over 2 times theta, and that's the same thing as pi theta over 2, I'm just saying multiplying it by theta over 1 here, okay? You can't bring the theta out. You can't bring the pi over 2 out of the cosine. You have to simplify what is inside of the function and then consider what the value of the function is for that value that's inside of for what you're putting in. So when we say the limit as theta goes to 1/2, we'll substitute directly theta equal to 1/2 into this and see whether or not it is in the domain of the function itself. And if it is, within this domain of this trig function, then we know that all trig functions are continuous in their domain, and we can use direct substitution, and it'll just be equal to whatever the value is. So when we put in 1/2 into this cosine, or into this expression here that's going into cosine as an input, we get pi over 2 times, and theta is now 1/2. Right? We can't bring any of this outside of the function. It's not possible for us to bring it outside of the function and still be correct. So we can simplify this though. So pi over 2 times 1/2 is the same thing as pi over 4. And pi over 4 is the same thing as 45 degrees. And we know that cosine is that's in the domain of cosine. Pi over 4 is in the domain of cosine. And from our trig tables or our memorization techniques, or if we put it directly into the calculator, we would get a value of the square root 2 over 2. And so we can use direct substitution on this. There's no problem with that. And that's the answer to the question. All right. So we'll put the rest in another video.